Today, I'm going to show you guys two ways to integrate 1 over square root of x squared plus 16. And this is a very typical calculus 2 integral that you have to know how to do. The first way is the classic trig substitution, and the second way is the hyperbolic substitution. And after the video, you guys can let me know which one that you like more. Starting with the trig substitution, notice that we do not have x on the top, because otherwise we could just use u sub, let u equal the inside, but we don't, it's just a 1 on the top. Trig sub is a good idea because we have a square root and we have a sum of two squares. So which of the functions do we use? Sine, cosine, well, you don't need to use cosine, sine, secant, or tangent. The answer is tangent, because we know tangent square plus 1 is secant square. And that's also on my board over there, my ultimate calculus 2 integration board. You guys can go ahead and check that out. So we start with x. The 16 is the same as 4 squared, so we need to multiply by the 4 and then tangent theta. From here, differentiate both sides. The derivative of tangent theta is secant squared theta. Don't forget the d theta. Now, going to the theta world, we have the integral 1 over square root. X is this, square this, and then plus 16. And then, don't forget the dx, which is this. Then, we are going to look at the inside of the square root and simplify it. I will show you guys all the steps. 4 square is 16, and then tangent square theta plus 16. And then we factor out the 16. And we see that tangent square theta plus 1 right here. That is going to give us secant square theta. And then square root of 16 is 4. Square root and the square cancel. We just get secant theta. And when we are doing integration with trig sub like this, when you cancel the square root and the square, you don't worry about the absolute value. And to see the detailed explanation, you guys can check out my other video for it. Now, this 4 on the bottom can cancel with this 4. One of the secant can cancel out right here. So we just have the integral of secant theta in the theta world. And this is something that we have to remember. The standard result for the integral of secant theta is ln absolute value of secant theta plus tangent theta. Is this on my board over there? Yes. Alright, we haven't gone back to the x world yet, so you don't need to worry about the plus c, just put it at the very end. From here, divide both sides by 4. We get tangent theta equals x over 4. Then draw a right triangle. Tangent is opposite over adjacent. Label the x here and the 4 here. And for the hypotenuse, you open the square root and you do this squared plus that squared. And that's precisely the original square root expression that we have from the integral. It's always going to be like this. Now, looking at this triangle, we can figure out secant theta, which is just hypotenuse over adjacent. So square root of x squared plus 16 over 4 plus tangent theta, which is just this right here. And usually we put the absolute value right here, but the 4 doesn't matter. And you see this part, it's actually always going to be greater than this. Because imagine if you don't have the plus 16, this is pretty much the same as that. But here we are adding the 16 inside, so this is bigger than that. That means the input is never negative, just parentheses is okay, and you're done. If you leave the answer like this, it's okay. No big deal, no problem on that. However, before we go to the hyperbolic substitution, I do want to mention that notice how we can put the over 4 together, and we can write this as ln of the top, which is just this, and then over 4, right, on the inside, but use the ln property, it's ln the top minus ln of the bottom, and then we have that plus constant. Now, if you call this constant C1, well, together because minus ln4 is also a constant, with the c1, you can just relabel it and call this 2 together c2. So sometimes you may see the answer written with just this plus a constant, and the reason is because you merge these two constants together. So either way should be fine. Now let's take a look at how are we going to do the hyperbolic substitution. So let me actually give you guys a brief review first. When we are doing the hyperbolic functions, there are two main ones, the hyperbolic sine and also the hyperbolic cosine. And they are called the hyperbolic is because they are defined on the hyperbola, this part right here, just this part. And this is x squared minus y squared is equal to 1. And we just care about the right hand side here. If you have a point right here, we will call this just like the good old unit circle definition for sine and cosine. The x value is the cosine, but this is the hyperbolic version. And the input that's use t, and the y is the sinh hyperbolic sine, and the input that's use t. So based on this, you can see that if you put this into x, put that into y, you have the most important identity, which is cos squared t minus sinh squared t is equal to 1. And of course, you can add this to both sides on the stuff. And I do also want to remind you guys that if you have cos t, you can use its exponential representation or definition. This is equal to e to the t plus e to the negative t over 2. And sinh of t is just minus in between. And of course, you can use this and that to verify it actually works right here. But no idea, it's actually much better. Now have a look. If I add this to both sides, then we see 1 plus sinh squared t will give me cos squared, right? It's just like completing a square. Two terms becomes 1. So here's how we are going to do it. We will start with x. Likewise here, we have the 6x. And just like what we did with the tangent substitution, we have to pay attention to the 16. Look at it as 4 squared. We need a coefficient 4, and I will be using sinh of t. Once you have this, do the usual business. And interesting enough, if you differentiate sinh, you get cos, and if you differentiate cos, you get positive sinh. You can use this to verify. Go ahead and try it. But anyways, dx is 4 cos of t dt. Now, let's go ahead and go to the t world. Integral 1 over square root. X is this now. Square that plus 16. And then the dx is this. 4 cos t dt. And then just like what we did earlier, let's simplify this part. We have 16 sinh squared t plus 16. Factor out the 16. And then here we go. Sinh squared t plus 1. You just move this to the other side. We get a cos squared t. And then when you cancel, right, square root and the 16 is 4. Cancel this and that, we just get cos of t. And have a look, cos of t in fact is always positive. So you absolutely don't need the absolute value right here. And this is so nice because 4 cancel, cos t cancel completely. So in fact, this right here is equal to the integral of 1 in the t world. In the t world, be really careful because the integral of 1 in the t world, you actually get t, not x. Then we have to go back to the x world. Look at this. We know that dividing both sides by 4, we see sinh t is equal to x over 4. So we can take the inverse sinh on both sides. T is nicely equal to inverse sinh of x over 4. So there we go. The answer for this is inverse sinh of x over 4, and then plus c. And then we are done. And also, you can think about how we can come up with an inverse expression. And you can also just think about how we can come up with an expression for the inverse sinh.